This is Bob Capetta from the College of the Florida Keys, and this lesson is on functions and graphs. So we're going to start with a discussion of domain and range. We can have a correspondence between two sets. The first set we consider the inputs. In the second set, we consider the outputs. So inputs could be questions like name of student, and output could be number of credit hours. For a given semester. So as of, let's say, the 10th day of the semester, so we have students' IDs at a certain school, so all of them are different, and the number of credit hours is unique. So let's just go ahead and say John Smith. Of course, there could be more than one John Smith. We will assume that John Smith is a unique student and he has 14 credit hours. Mary Jones has 13 credit hours. Bob Kent has 18 credit hours, etc. So the domain would be all of the students. The range would be the entire collection of outputs. Now, what makes something a function? So we have a relationship between two sets of correspondence. If we have a function, that would tell us that no input has more than one output. So you can't say that Mary Jones has 13 credit hours and 19 credit hours. Well, that doesn't make a whole lot of sense. So in our world of functions, we want to have a unique output for any given input. Now, certainly we could have a situation where two different students have 14 credit hours. For example, we could say Jane Murphy also has 14 credit hours. That's okay. We could have the same output for two different inputs, but you can't have two different outputs for a given input. That's how something is going to either be a function or not be a function. So if we're looking at examples of a relationship, if 1 is the input, 3 is the output, 2 is the input, 7 is the output, 3 is the input, 9 is the output, 4 is the input, 9 is the output. That's still okay, even though 9 is there twice. This is a function. The domain 1, 2, 3, 4, the range 3, 7, 9. No input has two different outputs. If we give an input two different outputs, then it is not a function. So if we say something like this, if we're given our relationship between our two functions, and we say 1, 4, 2, 5, 3, 11, 1, 9, now I have two different outputs for the same input. If that happens, what do we conclude? This is not a function. So that's something for us to work with. That's something for us to think about in terms of how these things behave. Domain is a set of all possible inputs. Range set of all possible outputs. And the notation that we use for functions typically looks something like this. I might say f of x equals x squared plus 5. If this happens, then what can we say? We can say the inputs could be what? Could be anything. Inputs all real numbers. You are allowed to do what? You're allowed to pick any number. You can square it and add 5, but outputs, the smallest output you could ever get is 5. So your outputs are all numbers greater than or equal to 5. The lowest number you are going to get is 5. So all numbers greater than or equal to 5. We could plug in some values. I could ask a question, for example, like what is f of -3? And you're plugging in the -3 for x. So where I saw an x before, I'm going to plug a -3 in parentheses. -3 squared plus 5, 9 plus 5, 14. And again, 14 is a number bigger than or equal to 5. Now let's take a look at a different function. This time, let's say g of x is the square root of x plus 4. Domain all allowable inputs. Now, we do not want to take a square root of a negative number. So I cannot use -5. -5 plus 4 would be -1. Square root of -1, not a real number. The smallest number I would be allowed to use would be -4, because -4 plus 4 gives me 0. Square root of 0 is a real number. So the domain here is all numbers, all real numbers, greater than or equal to -4. Now the range, you got to think about the range a little bit. Square root is always non-negative. The square root of something cannot be a negative number, but I could get 0 if I plugged in -4. -4 plus 4 is 0. Square root of 0 is 0. So the range of this starts at 0 and it gets as large as you want it to get. So all real numbers greater than or equal to 0. That would be our range for that function. Now, there's a way for us to determine whether something is a function. We can look at the graph. Remember, we said for something to be a function, each input must have one and only one output, or no more than one output. Each input must have no more than one output. So we can look at a graph of a function, inputs on the x-axis, outputs on the y-axis. Every input here has a single output. Every input has a single output, not more than one. So this is a function. But if we have a situation where a single input has two outputs, for example, if the graph looks like this input has an output here, here, and here. The vertical line cuts it in 3 points. So if a single input has multiple outputs, this is not a function. And that indicates to us what the vertical line test will be. So let's go ahead and say that. If a vertical line cuts a graph in more than 1 point, then the graph is not a function. Again, an input has to have a unique output. That is not acceptable. So let's take a look at some functions. Let's get used to the notation that we have. If I have f of x is 3x minus 4, what this is doing is telling me to take your number, multiply it by 3, and then subtract 4. So if I want to take a look at f of negative 2, wherever I have the x, replace it with negative 2. 3 times negative 2 minus 4. So f of negative 2 is negative 6 minus 4, negative 6 plus negative 4, negative 10. A single answer for a given question. You cannot have two answers for the same question and have it be a function. If I want to take a look at f of 5, remember f of x is 3x minus 4. We're going to plug 5 in for x. 3 times 5 minus 4. F of 5 is 15 minus 4, which is 11. So we can plug in values to get elements of our range. Plug in values of the domain to get values, elements of your range. Let's look at a more interesting function. If I have g of x is 3x squared minus 4x plus 1, what is g of negative 2? Wherever I have an x, replace the x with negative 2. 3 times negative 2 squared minus 4 times negative 2 plus 1. G of negative 2 is 3 times 4. Negative 2 squared is negative 2 times negative 2, positive 4. Minus 4 times negative 2 plus 1. I'm going to change that minus to plus a negative. Now I have g of negative 2. 3 times 4 is 12 plus negative 4 times negative 2 is 8 plus 1. G of negative 2, 12 and 8 is 20, and 1 is 21. And if, for example, I have big F of x is 2x minus 7, I could also ask for something like big F of c plus 3. What that's telling me to do is to plug c plus 3 in wherever I see an x. So to replace with parentheses, 2 times c plus 3 minus 7. So I get f of c plus 3 is 2c plus 6 minus 7. I'll make the minus 7 plus a negative, and I get f of c plus 3 is 2c plus negative 1, or if you like, 2c minus 1. How we can evaluate functions by plugging in values. We can also graph functions. Remember, we cannot have a vertical line cutting the graph in more than one place. So if my goal is to graph a function, something like f of x equals 2x minus 1, I can plug in various values. F of 0 is 2 times 0 minus 1. 0 minus 1, or 0 plus negative 1, which is negative 1. F of 1 is 2 times 1 minus 1, which is 2 minus 1, which is 1. F of 2 is 2 times 2 minus 1, which is 4 minus 1, which is 3. F of 3 is 2 times 3 minus 1, which is 6 minus 1, which is 5. How about some negative numbers? F of negative 1, 2 times negative 1 minus 1, negative 2 minus 1, which is negative 3. So I have all of these values, x and f of x values. So rather than an x and y chart, it's an x and f of x chart. So x is 0, f of x is negative 1, x is 1, f of x is 1, x is 2, f of x is 3, 3, 5, negative 1, negative 3. So we should be able to graph all of those points. So 0, negative 1, 1, 1, 2, 3, 3, 5, negative 1, negative 3. what is that going to look like? So 0, -1 is here. 1, 1 is here. 2, 3 is here. 3, 5 is here. -1, -3 is here. And you can see when we connect all those points, we get what is supposed to be a straight line. That is the graph of the function, and no vertical line cuts that in more than one point. Let's take a look at one more function for us to graph. Let's take a look at g of x equals x squared minus 3. We'll start with 0. G of 0 is 0 squared minus 3. You do the exponent first. 0 minus 3, 0 plus -3, -3. G of 1, 1 squared minus 3. 1 squared is 1 minus 3. 1 plus -3, -2. G of 2, 2 squared minus 3. 4 minus 3 is 1. G of 3, 3 squared minus 3, which is 9 minus 3, which is 6. G of -1, -1 squared minus 3. -1 times -1, +1 minus 3, 1 plus -3, -2. G of 2, 2 squared minus 3. G of -2, excuse me. -2 squared minus 3. 4 minus 3, which is 1. G of -3. -3 squared minus 3, 9 minus 3, which is 6. So putting all of these together, what do we get? One, 2, 3 on x. 1, 2, 3. -x goes up to 6. 1, 2, 3, 4, 5, 6 down to -3, 1, 2, 3. So my first point is 0, -3. So we have x and g of x, 0, -3, 0 on x, -3 on y, which is here. 1, -2, 1 on x, -2 on y. 2, 1, 2 on x, 1 on y. And then 3, 6, 3 on x, 6, 1, 2, 3, 4, 5, 6 up there. Continuing in this process, next we have -1, -2. -1, -2 is here. And then we have -2, 1. -2, 1, which is there. And then we finish off with -3, 6. -3, 6 is up there. And then we connect these points and we get a parabola that is the graph of our function. And again, remember, no vertical line can cut this in more than one point, and no vertical line does cut it in more than one point. So this indeed is a function. And that will conclude this lesson.